Hi, we're going to review for tomorrow's test on derivatives. Let me just make this a little larger. Okay, here we go. So for the first one, before you take the derivative, unless you want to use 3 quotient rules, you should just rewrite it. So we'll rewrite y. It's 1/5 x. Now, you never use negative exponents on the constants, on the numbers, but you use them on the x's. So if the x is in the denominator, it's going to have a negative exponent. So when you rewrite the next term, it's plus 7x. Since it's to the first in the denominator, it's to the -1 when you bring it up. Then you have minus 2x. It's to the half down there, so it's to the -1/2. Now you can get the derivative. So our derivative, y prime we can call it, is equal to 1/5, because it would be 1, the exponent is 1, so it would be 1 times 1/5 x to the 0, or just 1/5. Again, we multiply the exponent by the coefficient, so we get minus 7x to the -2. And multiply -1/2 by -2, we get plus 1. So I don't have to write it. X. And when you subtract 1, or 2/2 from -1/2, you get -3/2. So you can either leave your answer like that or rewrite it as y prime equals 1/5 minus 7 over x squared plus 1 over the square root of x cubed. But it's fine on this test just to leave your answers unsimplified. Okay, next problem, number 2. Okay, first thing we'll do is we'll rewrite it. So we have 5x to the 6/5 minus 7x to the -3/7. -3/7 plus 4. Okay, so now we can take the derivative, using our power rule. So when you multiply 6/5 by 5, you get 6. You write x. When you take away 1 or 5/5 from the old exponent, you get 1/5. Multiplying -3/7 by -7, you get positive 3. And when you take away 1 or 7/7 from -3/7, you get oops, I forgot to write x. You get -10/7. And the derivative of 4 is 0. So we don't have to write that. If you wanted to write your answer without fractional and negative exponents, you could write y prime equals the 5th root of x plus 3 over the 7th root of x to the 10th. You could break that up and make it x times the 7th root of x cubed, but don't worry about that. All right, now we start to get into some interesting problems. So whenever you go to take the derivative, you got to take a second and look. If it's not just adding or subtracting terms, if there's multiplication or division involved, you're going to have to use either the product rule or the quotient rule. You can't just take the derivative of each term separately unless it's just addition or subtraction. So here you see a product. So you've got the first factor, and then you've got the second factor. So when we get the derivative using the product rule, we do first. I'm just going to leave parentheses for now. So I'm just going to put the first. So we'll have room to put the first here. Then I'm going to have to take derivative of the second. Sorry, 2 prime. Plus the second. And then here I'll need the derivative of the first. Give myself a little bit of room. Let's hope I can fit it in. Okay. So first, that's fine. We just copy down secant x minus 3. Now this is where it gets a little crazy. If you look at the second, it's made up of a product plus x. So taking the derivative of plus x, that's just going to be plus 1. But to take the derivative of x cubed cotan x, we've got a little product rule. So now for this product, x cubed will be our first, and cotan x will be our second. So to take the derivative of just of that first term, the x cubed cotan x, I'll need a product rule, by itself. So I have first, derivative of the second is negative cosecant squared x plus the second cotan x times derivative of the first, 3x squared. Oh, I didn't leave myself room enough to take the derivative of the plus x. That was just the derivative of this first term. But I still need to add to it the derivative of the x right here, and that's just plus 1. So now I've got first times derivative of the second plus, put this in here, the second x cubed cotan x plus x times the derivative of the first, which the derivative of secant x is secant x tan x, and derivative of 3 is 0. So that's it. So we had a product rule within a product rule. Moving on. Okay. The next one, you can't just don't just start taking the derivative of the numerator and the denominator separately. It's a quotient, so you're going to need to use the quotient rule. So we're going to do low d high. So low is the denominator when we say that. D high is the derivative of the numerator. So derivative of tan x is secant squared x plus the derivative of 3x plus 3. So there's low d high, less, make sure you have a minus, high, tan x plus 3x. D low, the derivative of the denominator. The derivative of cosecant x is negative cosecant x cotan x. And the derivative of pi, that's a number, it's just 0. So far, we've got low d high less high d low. Don't forget, draw the line down below the denominator. Squared will go. And we're just leaving it. Okay. So then you get to number 5, and it looks horrible. It looks like if you just left it as is, you'd use the product rule, but for derivative of the first, you'd have to use quotient rule. For derivative of the second, you use product rule, so that would be a mess. So you're always on the lookout to simplify. And you can simplify here because cosecant x is the reciprocal of sine x. It's 1 over sine x. So when you multiply them, they multiply to 1. So really, y is just equal to 5x over cotan x. Now I'm going to do the problem like this with the quotient rule, but you could have also rewritten it as 5x times tan x, excuse me, and use the product rule. But I'll use the quotient rule. So we're getting the derivative. So y prime low cotan x. D high, derivative of the numerator is 5 less high, that's the numerator. D low is the derivative of cotan x, which is negative cosecant squared x. Make sure you're using parentheses, or else it's going to look like it's subtraction. You'll lose a point. Low d high less high d low, all over denominator squared. You can either put the cotan x in parentheses with the squared, or you can just put the squared there. That means the same thing. Okay. Now we get to the really fun one, 6. Now, the one thing I'm going to have to do, I can't simplify. I'm not going to simplify here. But that's 7 times the square root of x cubed. Realize that that's 7x to the 3 halves. Okay, so it's a quotient. The only problem here is that when we get to d high, the numerator, what we call the high, is a product. So we use the product rule to get d high. And then when we get to d low in the quotient rule, that's also a product. So that'll be another product rule. So we're going to wind up with 2 product rules inside the quotient rule. All right, so let's go. I'm not going to fit it on one line. I don't even hope to, but we'll try it. So we start low. So we have secant x rad x. D high. So since it's a product, we're going to use the product rule. So I'm going to have, maybe I'll use a different color to point it out. So D high is going to be a product rule. So we have first times derivative of the second. The derivative of sine x plus 7x to the 3 halves is going to be cosine x plus 21 halves x to the 1 half, because 3 halves minus 2 halves is 1 half. So far we've done first times derivative of the second. We still have to do plus the second. Yeah, I'm not fitting this on one line. 7, I don't know if you want to keep it in radical form. I'll just write it x to the 3 halves. So the second times derivative of the first is negative cosecant squared x. Okay, so far we have, let me just label this to see the big picture. I'm going to have to actually open parentheses for the whole numerator since I'm not going to fit it on one line. So let me just open that up. So we've got low, and all this was d high. Less, so we're still in the numerator, that's why I put parentheses here. High, so we're just going to copy the numerator, cotan x times sine x plus 7x to the 3 halves. D low, well, to get the derivative of the denominator, that's another product. And remember, square root of x is x to the half. So I'm going to use the product rule to get d low. So first, secant x times derivative of the second, 1 half x to the negative 1 half, plus the second, x to the half, times derivative of the first, secant x and x. Okay, so let me close the numerator. Let's see what we've got so far. We have low d high less, make sure you have the minus. This is the high, d low. So we're not done. Remember, with the quotient rule, it has to all go over the denominator squared. Secant x times x to the half, or square root of x. And that's it. Please don't try to simplify. Okay. So 2 product rules inside of a quotient rule. Okay, number 7, we're given y equals cosecant x. So find the first derivative. That you should know. The derivative of cosecant x is negative cosecant x cotan x. Now this symbol here means find the second derivative. It just means the same as y double prime. It comes from the fact that you're taking the derivative with respect to x of dy dx. And when you look at it, you see how you see d dy? It looks like d squared y. That's why they write it as d squared y. And then if you see the denominator, you see dx dx. So that looks like dx squared, but they didn't even put the parentheses. So it's just notation coming from what it looks like. What you have to know is that's just a way of saying the second derivative. Okay, so to get that, since the first derivative is a product, we're going to use the product rule. So I'll consider the negative cosecant x to be the first and the cotan x to be the second. So here we go. First, times derivative of the second. The derivative of cotan x is negative cosecant squared x plus, with the product rule, the second times derivative of the first. Now, you've got a negative there already, right? So it'd be negative times the negative 1 times the derivative of cosecant. So it'd be negative 1 times negative cosecant cotan x. So it'll just be positive cosecant x cotan x. And we can clean this up a little bit. So we wind up with cosecant cubed x plus cosecant x cotan squared x. Alrighty. Next one. Okay, we're asked to find, in number 8, the derivative at pi over 2. Whenever you're asked to find the derivative at any number, you always have to first find f prime of x first. So you do not have to use product rule here. Remember, when the first factor is a number, the constant multiply rule, you can just leave that there. I mean, if you use the product rule, you won't be wrong. You'll get the same thing. But when it's a constant multiplier, not being added, then the derivative would be 0. But when it's a multiplier, you leave the constant and you multiply by the derivative of what follows. Derivative of cosine x is negative sine x. So we get that our first derivative is equal to positive 3 sine x. Right? So if we want f prime of pi over 2, we're going to plug in pi over 2. Now remember, when you want the trig values of one of the quadrantal angles, you just look at the unit circle. Pi over 2 is up here. It's 90 degrees. The coordinates of that point are 0, 1. The x coordinate's the cosine, the y coordinate's the sine. So the sine of pi over 2 is just 1. And so we get 3 for our answer. All right, number 9. Given the function y equals the cube root of x, so that's the same thing as x, because there's a 1 here, to the 1/3, power over root. Write the equation of the tangent line at x equals 27. Okay, so remember to write the equation of the tangent line. It's going to be y minus, you're going to plug the 27 into the function to get the y1. So it'll be the cube root of 27. But then to get the slope, you're going to plug the given x value into the derivative. So I'm going to have to first get the derivative, but then I'll plug in the 27. That'll be my slope. And then just x minus 27. So we plug the given x value into the original function to get the y1 and into the derivative to get the slope. So we need to get the derivative. So y prime, using the power rule, equals 1/3 x. 1/3 minus 3/3 is negative 2/3. Now, other places I've just left the negative exponents, but since you have to plug a number in, it's kind of nice to rewrite it as 1/3 times the cube root of x squared. So now we can plug in the 27. So y prime 27 is going to equal 1/3 times the cube root of 27 squared. So 1/3 times the cube root of 27 is 3, and then we got to square it. So we get 1/27. And that's the only thing. Oh, actually, we should say what the cube root of 27 is, and that is 3. So this then is the equation of the tangent line. Okay, now it says find the y-intercept of the tangent line. To get the y-intercept of any function, right, you want to know where any graph crosses the y-axis. You take advantage of the fact that you know the x-coordinate of that point. So you already know the answer is going to be 0 something, okay? So I'm already going to start writing my answers, 0 something. I just got to figure out what that something is. So remember, to get the y-intercept, you put 0 in for x and solve for y. So we have y minus 3 equals 1/27, 0 minus 27. So y minus 3, 1/27 times negative 27 would be negative 1. And then you can add 3 to both sides. And so you get the y-coordinate there is 2. So my y-intercept is the point 0, 2. Okay. 10. Derive the derivative of cotan x using the derivatives of sine and cosine. So they're not just saying say what the derivative is. hopefully you know it's negative cosecant squared x, but we have to show that it's that. So we have to first rewrite cotan x as a quotient. Right? So you could be asked to derive the derivative of either cotan x, tan x, cosecant x, or secant x, because all of those can be written as a quotient, and you can use the quotient rule. I will not ask you to derive the derivative of sine x or cosine x, because that involves limits, and that's what we did in class. That's too much. But that's no problem. We know cotan x is equal to cosine x over sine x. So we'll use the quotient rule. So it's low. The high, the derivative of cosine x is negative sine x, less high. D low is cosine x, all over the denominator squared. I'll write it like this. Now we got to clean this up. So if we look at it, we get negative sine squared x minus cos squared x over sine of x squared. Now in the numerator, we can factor out a negative 1. And if we did that, if we factored out a negative 1, we'd have negative 1 times sine squared x plus cos squared x. For any angle, you need to know that that equals 1. So we have negative 1 times 1 over sine of x squared, or sine squared x. So it's negative 1 over sine of x squared. So you can think of that as being negative 1 times 1 over sine squared x, which would equal negative cosecant squared x. The good thing about a question like this is you know what the answer is supposed to be, so you can catch a mistake. 11. Okay, piecewise function, we want to see if it's continuous at x equals 0. So to be continuous, the limit has to exist, the function has to exist, f of 0 has to exist, and they got to be the same. So they're basically 3 values that you have to get, and they've all got to be equal. You have to find the limit of f of x, and you got to write this notation down. You can't just write numbers, okay? You got to actually show what you're finding. So the limit of f of x as x approaches 0 from the left. You're going to need to find the limit of f of x as x approaches 0 from the right. And if they are equal, you now at this point you know the limit exists. The two-sided limit exists. I just need to bring this up here a little bit. Sorry. So there are 3 values you need to find to show it's continuous. And you also actually have to get the actual value of f of 0. Okay. So to get the limit as x approaches 0 from the left, that means x is a number a little less than 0. We use the second branch. So we get 0 cubed plus 4, which equals 4. To get the limit as x approaches x from the right, we're going to plug 0 into the upper equation. So we have 4 minus 0 squared. That's also 4. So the two-sided limit exists. Now we just want to make sure we get the same value for f of 0. Well, we're in luck because there's an equal here. So we would do this. We would plug in 0 there. So f minus 0 squared is 4. So since all 3 are equal, okay, it's going to be continuous. But as far as the work that you have to show that you're getting the limit. Don't just write lim. Write the limit of f of x, whatever the function is called, as x approaches 0 from the left equals. Show that the limit of f of x as x approaches 0 from the right, what you get, and then also show that you're considering the functional value, because those 3 things must be equal in order for it to be continuous. Okay. since it's continuous, there is a chance it'll be differentiable. If we got no for this first part, we wouldn't bother. But now we want to see, okay, now we know the pieces are coming together. There's no jumps in this graph. We want to make sure when they come together that there's no corner. So to see if the derivative exists, the first thing you're going to have to do is write a piecewise function for the derivative. So the only thing that you want to watch out for, since you're trying to figure out if f prime of 0 exists, don't include the 0 in the first branch. Just have that x is greater than 0, have the x is less than 0. Okay, so if x is greater than 0, the derivative of 4 minus x squared is negative 2x. If x is less than 0, then we take the derivative of the second branch, and that's 3x squared. We want to make sure that the values of the slope, the limit of the derivative as x approaches 0 from the left and right, are the same. So now we have two values we got to get and see if they're equal. Now we have to get the limit of f prime of x as x approaches 0 from the left. And we also need to get the limit of f prime of x as x approaches 0 from the right. So we're going to do the same thing as we did for the first part, but we're using f prime now. So from the left, we're going to use the second branch. So we get 3 times 0 squared, which equals 0. The limit of f prime of x from the right, as x approaches 0 from the right, we'll plug 0 into the top branch. So negative 2 times 0 equals 0. They're equal. So the slopes are the same as the two branches come together, so it's going to be smooth, no corners. So is it differentiable? Yes. F prime of 0 exists. Okay, or you can just write the word yes. But just be careful with the notation. You know, you're not just writing the numbers. You need to show this part, you know, this notation. And you need to show this notation. You got to show what you're getting. You can't just write down the numbers. Okay? Same thing and down here. I want to see this. I want to see that you know what you're doing. All right? So to show it's continuous, you got to show the left and right hand limits of the function are equal, as well as the actual functional value, that all three numbers are the same. To show the derivative exists, you have to show that the left hand and right hand limits of the derivative are the same. Okay, next one. 12. Now you're given a graph, and you can't see it on what I have on my board, but on your notes it says there's a vertical tangent at x. So we have to remember that. Okay, so the first thing, though, it says at which the labeled x values is f continuous. As long as there's no hole, no jump, or no vertical asymptote, it's continuous. If you can sketch it without lifting your pen, it's continuous there. So, continuous at A? Sure. You know, technically, you're saying that the limit, the y it's approaching, is equal to the y it gets to at A. So A. B, it would not be continuous because even though the limit exists, f of b does not exist. So don't include B. C, it is continuous because the limit and the actual y value there, f of c, are equal. D, I hope my graph looks like yours. Yeah, the limit and the functional value are the same. E, no, because first of all, the limit doesn't even exist. So you would say it's pos infinity, but technically it doesn't even exist, so don't include E. F, it does exist, all right, because what the limit and the functional value are the same. And G, yes. Okay, again, you can sketch it without lifting your pen off the paper. It's good. Now, it says at which the x values is a differentiable. Well, the first requirement to be differentiable is that it's continuous. So don't even consider any of the other values other than the ones where you said it was continuous. So we'll go through those. At A, you want to make sure not only is it continuous, but no corners, cusp, or vertical tangents. So A is fine. It's nice and smooth. No corners or cusp or vertical tangents. So the derivative would exist there. Next one we would consider is C. C, even though it's continuous, there's a corner kind of cusp thing going on there, so we don't include it. Derivative doesn't exist. D, that's fine. No corner cusp or vertical tangent. Next one we had to consider was F. Oh, nope, can't include that one. There's a cusp or corner kind of thing going on. And G, if you remember, it said on your paper there's a vertical tangent, so we can't include that one either. So we just have those two values. Okay. 13, now we have a table, and this is one of those things I told you on the AP exam. Sometimes they want to see if you know your differentiation rules. So before you, they're asking you for the slope of this function at 2. That's another way of saying get the derivative at 2. So the first thing you always have to do is just get the derivative in terms of x, then plug in the 2. So first we'll just get y prime using the quotient rule. So we're going to have low, b high would be g prime of x, less high, d low, 3x squared, all over denominator squared. So x cubed squared would be x to the 6th, so you can just write x cubed squared. Okay, now you can plug in 2, because that's what they want us to find. So to get y prime of 2, it's going to be 2 cubed, which is 8, times g prime of 2. G prime of 2 is right here, times 3, minus g of 2, which is 0. So I don't even care that that's times 3 times 4, 12, because 0 times anything is 0, all over 2 cubed, which is 8 squared. We could cancel one of the 8s, and so we'd have 3 eighths left. All right, you could write 24 over 64, but that's the same as 3 eighths. So that's the slope, or the derivative at 2. So we found the rule first. And you know, I should have just written this out again with all 2's everywhere there was an x, and then shown you the values. I was trying to save space. I hope you followed that. Okay, for B, determine if f of x, g of x has a horizontal tangent at 1. So you can tell if a function has a horizontal tangent somewhere is if when you plug that number into the derivative, you get 0, right? A function has a horizontal tangent if the slope of the tangent there, the derivative, is 0. So we're going to see if when we get the derivative and plug in 1, if we get 0. All right, so let's get the derivative. We have to use the product rule. First times derivative of the second plus the second times the derivative of the first. Now let's see what happens when we plug in 1. I'm getting short on room again, so all right, so f of 1, let me just move this over. F of 1 is 3. Okay, so we have 3 times g prime of 1. If we look over here, that's negative 2. Plus g of 1, that looks like 2 to me, times f prime of 1, which is 3. So we wind up with negative 6 plus 6. We get 0. So the answer is yes, because f prime of 1 equals 0. Okay. I'm losing track. Okay. C. Find the equation of the tangent line of my to y equals 2g of x at x equals 2. So let me just write that down. Y equals 2g of x at x equals 2. So let's just set up how we're going to write the equation, the tangent line. It's going to be y minus, we're going to plug the 2 into the original function to get the y1. So it's going to be 2g of 2. That's our y1. To get the slope of the tangent line, we're first going to have to get the derivative. Now the derivative, we don't need to use the product rule because that's a constant multiplier. So we just leave the 2 and multiply by the derivative, g prime. So the slope of the tangent line we get by plugging 2 into the derivative. So it'd be 2 times g prime of 2. That's the slope, and then just x minus 2. So now we just got to go collect our values from our chart. I'll keep it here. I'll look at my paper. So y minus 2 times g of 2 equals 0. Okay. Equals 2 times g prime of 2 equals 3. So you can see our slope will be 6. And then x minus 2. So the equation is just y equals 6 times x minus 2. Okay, now we're going to go to the calculator part. We got to know how to use the calculator. We don't want to be dependent upon it, but we're given the function. I gave you one on purpose that you do not have to find the derivative of, so you have to use the calculator. When you want to find the derivative of a function at a particular value, you're going to use math 8. Let me just go to my calculator. Oh, I got to clear this stuff out. Oh, no, I'll just go. Okay, so to find the derivative of any function, you press the math key and then choice 8 and derive. You always fill in the x down here. That's telling you that the variable is x. Now we got to put the function in here. So I have to put in the ln of the absolute value of x. To get the absolute value, you go to math, number, and it's right there. We can put the x in here. And we want the derivative at 5. I believe I'm just checking. Yes, 5. So at x equals 5. Enter. So sometimes the calculator is off a little bit. You know, in this class in general, always, you don't have to round more than 3 places after the decimal. So we're just going to write down 0.2. If you want to write out the whole thing, fine. Now the second part, we're asked to graph the derivative. Remember, the calculator will not tell you what the derivative of a function is, but it will graph it. So to graph it, you go back to the y equals screen to graph something. Let me just clear this stuff out. Sorry. Okay. To graph the derivative of a function, you go to the y equals screen, and again, you want the derivative, you press math 8. You put in the x down here as always. You put the function in the parentheses, so we said the ln of the absolute value, math, number, absolute value of x. But here's the part that's different. When you're graphing the derivative, you want the calculator to find the derivative at all the x values, not just a particular one. So it's x equals x. Now we'll go to a window. I'll press zoom 4. So to graph it, press zoom 4. And I'm just going to sketch what I see. Just a sketch, so I know that you're entering it properly. Okay, now 15, go back to our board. Okay, so we said this one was 0.2, and this one, we had a graph like that. Okay, 15. They're telling you that f of 2 equals 3 and f prime of 2 equals 5. And they want us to first write the equation of the tangent line. Well, this is actually all set up for us. Because to write the equation of the tangent line, well, I should have said at x equals 2. Oh, I have it at the end here. All right, so the equation of the tangent line at 2, it's going to be y minus, you plug 2 into the original function to get the y1. And to get the slope of the tangent line, you plug 2 into the derivative of the function. Normally, you have to work to get that f prime of 2. You usually have to get the derivative, plug in 2. But here they gave you the number. So it's y minus f of 2, which is 3, equals f prime of 2, which is 5, times x minus 2. That's it. For part B, so that was part A. B, you want the equation of the normal line. It'll be the same thing, but because the normal line is perpendicular to it, the slope will be the negative reciprocal. So that's that. Okay, so moving on to 16. 16. A, find all points where the function has horizontal tangents. Remember, now it says points, so I think we should get the x and y coordinates. So remember, a function has a horizontal tangent wherever the derivative equals 0. So we're going to get the derivative, find out at what x values it equals 0. All right, so you're looking for horizontal tangents. You're going to set the derivative equal to 0, and then you're going to solve for x. Okay, so the derivative, I think I'm going to do my work down here so I have more room. So the derivative, f prime of x, is equal to 4x cubed minus 8x. So we have to set the derivative equal to 0 and solve. So to solve equations when one side is 0, factoring is always a great way to do it. So we're going to write this side as a product. We can factor out a 4x. So if we pull out a 4x, we've got x squared minus 2. Now, the reason we factor to solve equations equal to 0 is because we know a product equals 0 when either factor is 0. Well, 4 is a factor. That's never 0, so forget about that. So if you set this factor equal to 0, x is 0. Now, some of you need to see a t in order to understand what's going on, so I'll write it. If you set the third factor equal to 0 and solve, you could add 2. You get x equals plus or minus rad 2. So we found the x coordinates of the points where it's going to have a horizontal tangent. To get the y coordinates, so we've got 3 points. We've got 0 something, we've got negative radical 2 something, and we've got positive radical 2 something. To find the y values, you have to go back to the original function and plug in the x. So I'm just going to write that up here, x to the 4th. So our function is equal to x to the 4th minus 4x squared. So let me just give myself a little more room here. Okay, so if x is 0, the y value is going to be, so f of 0 will be 0 to the 4th minus 4 times 0 squared. Well, that's just 0, so the y coordinate's 0. Now, I know this next one's going to bother you, but if to get f of negative rad 2, we're going to take negative rad 2 to the 4th minus 4 times negative rad 2 squared. Well, negative rad 2 to the 4th, first of all, it's going to be positive. If you square it, you get 2. And if you square that, you get 4. And then minus 4 times negative rad 2 squared would just be 2. So 4 minus 8 is negative 4. If we plug in the positive rad 2, we get rad 2 to the 4th minus 4 times rad 2 squared. So again, we get 4 minus 4 times 2, or negative 4 again. It was an even function, so we should have known we get the same y. And those would be the 3 points where the graph would have horizontal tangents. Don't worry, they're not going to be that as hard on the test, but You got to practice this stuff. Okay, the part B. Find an equation of the tangent line at x equals 1. So we need to get the derivative, which we have. Remember, to get the tangent line at 1, it's going to be y minus f of 1 equals the slope of the tangent, f prime of 1 times x minus 1. Okay, to get f of 1, to get the y value, plug 1 into the original function. 1 to the 4th minus 4 times 1 squared. 1 minus 4 is negative 3. Maybe I'll write that over here. Oh. So we have y minus negative 3. So y plus 3 equals f prime of 1. We'll plug the 1 into our derivative. 4 times 1 cubed is 4 minus 8 times 1. It's minus 8. 4 minus 8 is negative 4. So our slope, where am I here? I'm sorry, I lost my, oh yeah, we said it was negative 4, and then it's just x minus 1. So that would be the equation of the tangent. And then find the equation of the normal line. Let me just erase all this. Once you have the equation of the tangent line at a value, the normal line is the same, but because it's perpendicular, just the slope will be different. It'll be the negative reciprocal, so it'll be positive 1/4. And that'll be the answer to C. Wow, that was a lot. Okay, let's see how long that took us. 46 minutes. Wow. Okay, so hopefully this worked. See ya.